All right, this is part 2 for the weather basics. I'm on the third slide that reads air pressure. Over here, let's just hit the highlights. Generally, warm air is less dense. This creates low pressure and allows air to rise. Guys, remember, when air is heated, it expands. Okay, the air molecules move further away from each other. They will collide less, which means low pressure. But because the air has expanded, it's less dense and it's going to rise. Okay, and then because this air is rising, other air has to flow in to take its place. Okay, that's what creates winds. Remember, wind goes from high pressure to low pressure. On the other hand, cool air is more dense and it tends to sink. This creates high pressure and prevents rising air. Generally speaking, in high pressure areas, you don't have many clouds. And again, air flows from high pressure into areas of low pressure to kind of create these convection cells that we're familiar with. Okay? So warm air rises, cooler air sinks. Warm air rises because it's less dense and has less air pressure. Cooler air sinks because it's more dense, the molecules are closer together, okay, and has more air pressure. All right, this is another example of basically the same concept. You have warm air rising because it's expanded, it's exerting less air pressure, it's less dense. It rises, and we have the word cyclone here. Cyclone really, in general terms, just means low pressure. So when we talked about tropical cyclones, we were talking about storms with organized circulation that were low pressure centers. Tropical cyclones can get to be very, very intense low pressure systems, but a cyclone just generally means low pressure. Whereas anticyclone means high pressure. I'm not worried about you knowing these terms as far as low pressure and high pressure. Okay, I want you to understand what low pressure air and high pressure air does and how that affects weather. So high pressure air tends to be cooler and it sinks because it's more dense. Low pressure air tends to be less dense and it rises. And because it rises, it will then often form clouds. Sinking air, high pressure air, typically does not form clouds. Okay? All right, then we have something that you will find often on weather maps, and that is the concept of isobars. An isobar is a line on a map that connects areas that have the same air pressure. So here, this particular line is marked with 1008, which means that air pressure, every location along this line has an air pressure of 1008 millibars. Okay? Every location along this line has an air pressure of 1012 millibars. Every location along this line has an air pressure of 1016 millibars. What would my air pressure be if I lived right here? Well, I don't know exactly what it would be because I'm not on a line, but I do know that my air pressure is going to be less than what's on this line, so less than 1012, but more than 1008 because I'm sitting here between 1008 and 1012. Okay? Now, you're also going to run into some maps that have other lines that mark temperatures. And so you're kind of wondering, well, how do I tell the difference? Guys, we're not going to have air temperatures of 1016, 1024, 1020, 1008. Those are not reasonable air temperatures. Okay? They are reasonable air pressures because your average air pressure if you're standing at sea level is 1013 millibars. Okay, so these are all in the range of a typical air pressure. Okay. All right. A little bit more just to remind you. A high pressure center is often marked with a blue H, blue kind of just to remind you that it's colder, denser, sinking air. Generally speaking, high pressure goes with sinking air and cloudy skies. Okay, you're not going to have clouds forming because the air is tending to sink rather than rise. Low pressure centers are marked usually with red L's because red, we kind of think of warm when we think of red. Okay, so this is warmer, less dense air that's rising. Because the air is rising, the clouds are more likely to form. Okay, so let me show you what this might look like on a weather map, Okay, so this is obviously not the type of weather map that you see the weather forecasters on the news using because it's a little too complicated. But this is one that forecasters may look at. And you see these dark red lines here and here, here, all of these. These are all isobars. They are marking locations that have the same air pressure. Okay. If I have a loop with an H in the middle of it, well, this is a high pressure area. Okay, it's interesting on this particular map that I have a low pressure marked right beside it. That's kind of unusual, but the dark red lines are isobars. They mark or they connect lines, or they connect areas that have the same air pressure. Okay. All right, so we've just covered 5 slides all about air pressure. I don't really expect you to have something unique to say about every single slide, but figure out something that you have learned from these 5 slides and add something. You know, even if it's just a reminder that warm air rises and cooler air sinks, or that if you're between isobars, you can estimate your air pressure because you can look at the 2 isobar lines that you're sitting between, something like that. Okay, and then join me for the next set of slides, which is going to be about frontal boundaries.